Hi everyone. Today we are gonna carry on with our questions. Last lesson we start with it to explain what we are gonna learn in mechanics topic. Today this is our first lesson with questions and answers. Let's see our questions. Number 1. Okay, in this question what we see, let's read question now. Let's see question what we have. Mass is 75 kg, and then bicycle mass is 25 kg. So it looks like we must add to get total mass. And resultant force is 400 newtons. Calculate acceleration. Okay, please read question and please try. Okay, just you can stop video and then you can try first, and then you will see answers and we are going to explain it. You have mass 75 and 25, total mass you can calculate it, and then resultant force is 400 newtons, and we are looking for acceleration. All right, we can carry on. So just I was waiting a few minutes, but we cannot wait for you 10 minutes to try, but please just pause, stop video, and then try. After that, you can see your answers. All right, so we are using that option. Okay, now let's see our solution. For this question, we are going to use Newton's second law. First of all, we can draw free body diagram. Draw a force diagram, free body diagram we can draw. First of all, F net. They are not talking about friction force, apply force, only F net, directly F net is given, as you see. We can just use F net. F net is 400 newtons. And then we need total mass, because moving together, just everything, we have to calculate all mass, total mass. 75 and 25, total mass is 100 kg. What we know about Newton's second law, F net equals mass times acceleration. So we can calculate the acceleration from this formula. We can take acceleration equals F net over mass total, 400 over 100, and then you are getting 4 meters per second square. Just direction, they said west, direction is given, but let's see in question it is given. Yeah, the direction depends on the direction of motion also, you can say. In question also they should say direction is west, direction of motion same. Okay, this is our question 1. Today we are going to try to answer with you 5 questions. Let's see other questions. If you have any question, if you don't understand any point, just share with me, and then I can try to help you. Okay, let's continue with next question, question 2. Question 1, using Newton's second law, we know F net, we are calculating total mass, and then acceleration equals force over mass. Done. Let's go to next question. Okay, now calculate the acceleration of a 25 kg box that's experienced at 75 newtons applied force, and friction force is 12,5 newtons. Okay, now F net is not given, but what we know, applied force and friction force. Friction force also with Newton here, you can just add it. Friction force with Newton, of course. First of all, please try. As you know, just you are going to try first, and then you will see answers. Calculate acceleration. If you have 25 kg boxes and then your applied force is 75 and friction force is 12,5 newtons. Good luck. Please try. Now we can show our solution. Calculate the acceleration of a 25 kg box that experienced at 75 newtons applied force and 12,5 newtons friction force. First of all, we can draw our free body diagram. Free body diagram means, people, just forget about all boxes, system, everything, just everything on a point. All right, just you are just drawing all forces on point. First of all, we have applied force starting from point. Start this tail of first force, apply force must be this point, and then tail of friction force also must be this point. If you have another force, you must just add. Free body diagram means, people, just putting dot and then using all forces on this dot. After that, easy to calculate, easy to get net force. Now we have applied force 75 newtons. This is our step one. Apply force 75 newtons. Friction force is 12,5 newtons. And we are calculating net force. Net force, you can use this formula. Net force equals big force applied force minus small force. You can use this option, or you can say the one side positive. Let's show that option also. Maybe you like that one and you can carry on with that. So you have positive, let's say to the right is positive and this side negative. And then you can say F net equals F1 or F applied plus F friction, you can say. And then F applied is 75, as you see, it is positive, and plus friction force is negative because direction you are choosing negative, 12,5, and you are getting 62,5 newtons. So you are getting positive. So this positive is showing you direction of net force this way. So direction of force, you can say direction of motion. If direction, yeah, to the right or east, you can say. I hope it is clear. You have two options to get net force. And yeah, first option, big force minus small force. Second option, you are choosing positive and negative, and then you can finalize. If you are getting positive, your net force direction positive, and then east, and then if you are getting negative, maybe other question you have negative. If you are getting negative, so your direction west. That's it. So F net also done. From now, just like question one, do you remember getting the acceleration using Newton's second law? Newton's second law, what was it? Mass times acceleration. And then we have another video, people, about all definitions. What is Newton's first law, second law, what inertia? Just you can see those videos also for all definitions. All right, for now we are focusing to questions. Each video will try to make 5 questions for you. But for definitions, please see other videos. So let's continue. Acceleration equals F net over mass. And then F net you calculate 62,5 over 25. And then you are getting 2,5 meter times second power of negative 2 to the right or east, you can say. We have done question 2. I hope everything is fine. If you have any question, please let me know. Let's continue with next question. Now, number 3. Okay, this is different question. Now we did use Newton's second law. Now we are busy with gravitational force, universal gravity. We are gonna be busy with that. First of all, let's see our question. You are gonna try first, of course. Please pause video, please stop video, and then you can try first, and then you will see answers with me. Weight of this man is 735 newtons. Maybe you can say how it's possible. Weight, guys, it's not mass. Okay, in our daily life, we're just using weight as our mass as a weight, but it is wrong. Weight is different, mass is different. Weight equals mass times gravitational acceleration. Okay, and then if the mass of the planet B, so for now, he is on planet A, on surface, not flying like this. on surface planet A, 735 newtons. But if he's going to planet B, and planet B is 3 times greater than planet A, so mass of the planet B is 3 times greater than of the planet A, we know that. And then radius of B 2 times greater than planet A. Find the weight of the astronaut on the planet B. That's our question. Let me just draw and explain question, and then you can try. Let's draw what they're asking. With diagram, it's gonna be much better for you. Okay, first of all, our astronaut is here on planet A. Our friend will help you now. So, first of all, let's write, let's say RA. And then for this one, mass, let's say MA. What else we know? Weight of astronaut we know, WA equals 735 newtons. And he's going to planet B. And if he's going to planet B, RB is here, and then MB is here, and then our friend is coming to planet B. He's not happy now, I don't know why. So MB, RB, MA, RA. So radius of planet A is RA, radius of planet B is RB, and then mass is MB. What we know, people, MB equals, how many times they said? 3 times. 3 MA, number 1, and then RB equals 2 RA. We know these two things. And then what they ask people, what is weight of the guy on planet B? That's our question. As you see, radius of planet A, planet B, we don't know. Okay, it's your turn. Please try. Please stop video, otherwise you are going to see answers now. All right, now, people, how we are going to answer these kind of questions? First of all, we should use our gravitational force with formula. If you have any object, for this one, for example, let's say mass of this guy is M, and the mass of planet is MA. So how can we calculate gravitational force or weight of this guy? Weight equals G times, G is constant number, people, 6,67 constant number. You will get it during exam, don't worry about that. It is constant number, just like gravitational acceleration. And then M1 is M for this guy, and then MA for planet O and RA squared. So if on planet, on surface of the planet, you can use directly RA. But if he is away from surface, you should add. Another question is coming, because we need distance between center of planet and that guy or any object. All right, we are using this formula for A, and then you can write, you can take M front, or you can change, G is here. So this is our WA, means weight of the guy on planet A. Same thing for planet B, you are writing, but before you write this step, let's write for WB. WB equals G times M times MB over RB squared. So from now we can go to this step. Please check. M still here. We don't have to touch it. G is here, it's fine. But for MB, you are writing 3MA. Why we are doing that? Because when you go to next step, you can just cancel them. All right, to cancel out, so we are using everything with MA. All right, everything on planet A, because we know already MB 3 times bigger than MA. We are writing 3MA. And then for RB, we are writing 2RA. I hope it is okay. After that, we are going to next step. Next step, M already here for WA, for weight on planet A and weight planet B. We are writing like this. MG, MA over RA square. It is fine. It is for first one, exactly same. Just writing the only swap, just MG, it's fine. Even you can leave it like this, still fine. And then for next one, MG, 3MA, and 4RA square. Why 4RA square? People, 2R, because 2 square is 4. 2 times 2, 4. From now, you just cancel them. Mass, gravity, all gone. Constant numbers gone. MA gone. MR, MA this side gone. RA square, everything gone. RA square is gone. What is left, people? On top, only 1. And this side, 3 over 4. So this numbers left. If you have 1 over 3 over 4 in maths, you know already, we can write 4 over 3. And from now, how can we get our W? What we know, people? WA is given 735. We are looking for WB, weight on planet B. So we are looking for that one. From now, just cross multiplication. And 4 times WB equals 3 times 735. When you multiply this and then divide by 4 each side, 4 cancel each other, only WB left here, what we are looking for. And when you calculate this, you are getting 551,25 newtons. If they ask you direction, people, what can we say? Always just going to planet. Just let's write towards to planet A. Because if you are calculating any force, planet B, sorry. If you are calculating any force, people, you should say direction. If in question, if they are asking you on the magnitude of force, it's fine. You don't have to say, you don't have to talk about direction, but otherwise you have to say, you have to mention direction. I hope it is clear. I hope it is fine. It looks difficult, too many things, but everything coming from this formula, people. WA, weight of A is like this, and you are writing for B, same thing for planet B. After that, just cancel them each other. That's it. Only we have to know how many times bigger, mass or radius, how many times bigger. All right, this is our question 3. I hope everything is fine. One more time, I'm telling you, people, if you have any question, any problem, please let me know. Let's continue with next question. Okay. This is similar question, but now directly asking gravitational force, directly asking mass, even givens here, but you don't need that for now for question. Okay, it's fine. Please check. You have an object moving around the Earth, and the mass of the object 2,000 kg. And mass of the Earth is 6 times 10 to the power of 24 kg. What we know, people? Oh, givens already here. Okay. We know mass of object M1, or you can use small m, or capital M you can use for this. After that, total distance between object and center of the Earth. R, we need R. So what we know, let's draw our diagram for now what's going on, and then you can try. People, you have just one object moving around space. Let's draw ugly one. Nice one is here. You can see that. Okay, so distance from surface of the Earth to object is 100 kilometers. And then radius of Earth is given RE, let's say, Earth RE. What's that? 6,4 times 10 to the power of 6 meters. Okay. Do you remember what we said? If your object not on surface, we need total distance to calculate our gravitational force, other name is what? Weight. We know mass, 2000 kgs. What we are looking for, people? W. W, A, B, it doesn't matter. We are looking for weight. Other name is gravitational force. All right, this is your question. It is your turn to try. Maybe I can write formula also, because during the exam you are having formula. But some schools having, some schools they don't. Okay, just leave it. Formula, you are using gravitational force formula. It's time to keep quiet and you are gonna try. Please stop video. All right, let's continue. Let's see our solution. People, first of all, this is our formula, gravitational force formula. What we know, force equals G times M1 times M2. And what is our M1? What's our M2? Let's write now. G is constant number. You will see now 6.67 times 10 to the power of negative 11. And times M for object. And then we are using ME, mass of Earth, and R, total distance. People, how we are getting total distance? First of all, 100 kilometers plus 6.4 times 10 to the power of 6 meters. It is our first step. We must convert to meters. As you see, 1 times 10 to the power of 5 meters, because 100 kilometers equals 100,000 meters. If you have 100,000 meters, you can write 1 times 10 to the power of 5 meters. And then you are adding, when you use your calculator, you are getting this distance between center of Earth and your object. From now, easy to calculate. We are just writing all givens, everything. This is constant number, you are getting it. Mass is 3 times 10 to the power of 3 because it was 2000. And then mass of Earth is given 6 times 10 to the power of 24. And then you calculate all distance, total distance from center of Earth to object. After that, you are calculating and you are getting 1.89 times 10 to the power of 4 newtons. Direction also we are writing and done. I hope it is getting easy for you. So we are going to carry on with this kind of questions, people, in our next video. Now we are going to our last question for today. Question 5 is coming now. But please let me know if you don't understand any points. Okay, let's continue with next question. Now we are going to question 5. But let's clear all drawings. Question 5. Now, let's see. Similar question to number 3. Yeah, number 3. Now planet A, planet B, similar one. All right. People, weight of astronaut on planet A is 800 newtons. Let's write all givens, and then you are going to try. After that, we are answering together. Let's write what we know. Okay, let's draw one more time. Planet A, planet B. If you don't remember number 3, question 3. Our friend is coming back. Now he's happy. So planet A is here. What we know, let's say RA for this one, and then MA for planet A. After that, mass of the guy, let's say M. And we are going to planet B, 2 times less than planet B. Mass 2 times less, but radius 2 times bigger, 2 times bigger. So we are drawing bigger one, because they said 2 times bigger, maybe not 2, but it's fine. RB is here. And then we have MB, and this guy coming to planet A, from planet A to B. Now we see he's here. Let's see. Yeah, he's also happy now. That's good. So mass is M and radius is RB. Mass of the planet B is MB. Now what they ask and what's else given? WA is given. Weight on planet A is given 800 newtons. And we are looking for weight on B. This is our question. Okay, it's time to try. And you are going to get 100 newtons. If you are getting 100 newtons, your answer is correct. Okay, we are going to answer with you now. Please try. It's time to pause video and then try. This is our question 5. All right, let's continue with our solution. This is our last question for today. Let's continue with question. Question 5. Question 5 is coming. Yes. Now they said calculate WB, weight of this man on planet B. Let's remember our formula. What was our formula? Gravitational force. Other name is weight. Weight equals, for A, let's write first. Weight equals G. You know G is constant number. And then M for this guy, mass of the man. And then times by MA over RA squared. This is our first formula. And then second one, what is second one? We are writing for B. Let's change our color. Let's continue with B now. Let's see, WB equals G times, it looks like 6, but it is G, people. M times MB over RB squared. That's it. Okay, from now, we are trying to cancel each, so you can use WA over WB, and then on top you can write G times MA over RA squared over G times MB over RB squared. From now, what we know, people? MB is 2 times less than MA. So you can write here MA over 2. Let's write one more time. G times MA over RA squared over G is still same. Just write it again. And M is fine. Now we are writing MA over 2. Why? Because less time, 2 times less. 2 times less. Over, what about RB? RB, they said 2 times greater than RA. So you can write, if you want here, RB equals 2RA, and then MB equals MA over 2. Okay, what we are writing, 2RA. 2RA squared. From now, what are we gonna do? We are gonna just cancel all same things, all same symbols. We are gonna cancel. Okay, let's change color one more time to make it easy to see. All right. Let's see what we have now. Step by step, all let's show. Let's continue. WA over WB equals what we have now, G times M times MA over RA squared, and then G times M times MA over 2. And I'm writing one more step to see, people, what's going on. Otherwise, you can say we can cancel also here, but let's write that one more step to make it easy. 4RA squared, people, because do you remember 2 square we are using now? From now, we are gonna cancel them, what we don't need, what is same, because if you have too many unknowns in questions, you cannot answer your question, it's gonna be difficult. So now let's cancel G, cancel mass, because M over M making 1. So MA, gone. RA squared, gone. And from now, what is left? People, WA we know already, it is 800. So we can write 800 for that. 800 over WB equals, what is left on top? Nothing. It means we can write 1. Please don't write 0 by mistake. 1 left. And then here, 1 over 2 over 4. Left. 1 over 2 over 4. So from now, you must make your plan. 1/2/4, what is that? You can use your calculator or you can just remember maths. If you are okay in maths, you can get it. So finally, you are getting 8 for all, 8/1. So 800/WB equals 8/1. And cross multiplication from now, 8WB equals 800 and divide by 8 for each side. And finally, your answer is 100. Let's write WB equals, remember we said answer is 100. WB equals 100 newtons. Direction, we can write, let's write here, direction towards to planet B. Planet B. So, okay, next time I must use nicely, writing, sorry about it. But I hope you get it. So, do you know what are we doing, people? First of all, we are writing formula for gravitational force for planet A, and then same thing for planet B, and then weight A over weight B, and then you are just writing which one, how many times bigger, how many times smaller. After that, cancel what you don't need. Only this one, if you are not good in maths, will be difficult for you. So maybe this step also we can explain with another page. Let me just do it. Let's clear all. And then let's explain this one, 1/2/4. What's that? So let's explain maths now. 1/1/2/4. How we are gonna get, your equal is just here, how we are gonna get 8 for this. It is 4/1, people. 1/1/2 times 1/4. First one just stays same, and the second one you come to change it. After that, 1/1 also you can say on top. 1/1 and then 1/8 left. So first one writing still same, 1/1 times 8/1, because second one must just swap, must change it. Finally, you are getting 8/1. I hope it is clear now. It is a long process, but if you are good in maths, you will see, people, or directly use your calculator. Also, you can get, but sometimes calculator just you can have a mistake because of that. Please be careful. So where is your main one is here. So please be careful and answer this one. Let's see how was it. Let's just go back and then we will see our question, our solution one more time, and then we're going to finalize with you. So this is our solution for question 5. Thank you very much. See you next lesson. Today we are going to finish now. Every lesson I will try to answer 5 questions with you. We start with mechanics and then we are going to carry on with other topics. Mechanics, it is our lesson 2. Lesson 1, I did try to explain what we are going to learn. And for all definitions, people, you can go to other videos. Okay, for definitions, we don't need to just read, and you can study, you can memorize all definitions, but calculations, all questions, we are going to carry on like this. See you next lesson, lesson 3, mechanics, lesson 3. See you next lesson. Have a nice day, everyone.